Hey everybody, I thought we would go ahead and continue building our 3-axis controller board for our CNC machine. If you missed the other videos about this board, I'll leave a link up here and you can watch other videos about this kit. This is a kit that comes from a place called Hobby CNC, and it will build a 3 or 4-axis controller for a CNC machine. And we left off with step 19 and we installed some components, and we were to do some testing before finishing the build to make sure that there were no errors. So I'm going to jump right in with that testing and then try to finish up the rest of the components. So let's get started with the build. So looking back at our instructions, you can see where we marked off number 19, and that was the last thing that we did. And now there's a paragraph of how we test this board before we start step 20. And it describes putting 12 volts on the board and then testing for 5 volts to make sure that it's assembled right up to this point. So what it wants us to do is apply 12 volts here to those two leads, plus and minus, and then over here there's a pad that says plus 5 volts. It wants us to test to make sure 5 volts is on there. So let's go ahead and rig this up and we'll do that test now. To do this test, I'm going to use my homemade power supply right here. This was an old PC power supply. You can see where I cut the wires off here. This is where they would come out here. This side probably looks familiar from the back of the PC. And I mounted the switch here, and then I brought up some banana plugs with 5 volt and 12 volt on top here, and then my ground. So this makes a nice little bench top power supply if you're ever in need of that. If you ever do electronics, you probably need one of these. So I've got my banana plugs, and I can put the black one in ground and the red one on 12 volt. Let's go ahead and hook this up to the board. I just cut a couple pieces of wire here, and I'm going to attach them to the board with this terminal. And my negative. And I'll connect them to the power supply with these clips. Let's get our meter. Okay, so I have my meter set on 20 volts so I can check for 5 volts, and that 5 volt pad is right here, so I'm sending 12 in and I should expect 5 volts out here. So let's go ahead and turn on the power supply. I'm going to put my negative lead on the negative thing here and touch off on this. 5.07. So there's my 5 volts, and that's within tolerances. So I passed the test. Now I can continue on with the other steps. So I checked that one off. Step 20, install the Hex Inverters U8 and U9. Orientate the notch as shown on the silk screen. Trim the leads. These are our Hex Inverters here. So looking at my board here, this is U8 and U9 over here, and the silk screen shows the little notch up here on the top. So I take my hex inverter, and you can see there's a notch here as well, so that just goes up like this. So now I have to put this right down in the hole there, line it up and press it in. There's one. There we go. I don't know why they didn't send me sockets for those, but they didn't. That's okay. I don't have any, or I'd use them. Let's flip that over and solder them. So using my cheap soldering iron, I will put in the inverters. Looks good. Just want to check it with a magnifying glass. Make sure I've got all of the pins well soldered. Looks good. And just clean it up with an old toothbrush. Okay, we've installed our Hex inverters. Now it's time to install our driver chips. And there's 3 of them, and they go in U1, U2, and U3, and they can only go in one way. Trim the leads. It says do not install U4. Now, if you look at this board, let me go over there real quick. This board is set up so they have a 3 or a 4 axis controller, and if you buy the extra parts, you can turn it into a 4 axis. But I've just got the 3 version, so I won't need the driver chip for that. That's what it's talking about. So I put them in here, U1, U2, and U3. And here's the driver chips. Look at those weird pins. Yep. Well, I can tell these are going to be fun to put in. Well, I got lucky. Here's one. I won't do that. There we go. One more. So I guess what I'm doing is I'm lining up one side, and then with it partially held in, I'm kind of bending it to fit the other pins in. And I have noticed too, if you take this before you put it in and you kind of bend them to the corner of a table so they're all in a line, straight line, that helps too. You don't want to break these pins off. What a pain, man. Alright, so I'm going to push these down all the way. And the heat sink will go across here when we're all done. I'll get a piece of aluminum and I'll mark it out and tap it for these holes. So anyway, time to solder all these connections up. I like to tack each corner of these before I do them all, you know, so they don't move on me. Just tack them in. Then I'll come back and do them all. I wonder if they make a socket for these particular driver chips. I've blown these driver chips out before. If, you know, 2 of the stepper motor wires touch or something like that, you can blow these chips right out very easily. So you want to be very careful when you're hooking your wires up that you don't cross touch or, you know, don't hook your wires up correctly, because you will take these chips out. And I can tell you, they're very hard to get out of here. And I don't know if they make sockets for these or not, but if they do, I would recommend getting them. I should have looked that up before I built this one, but I didn't. So I'll just be extra careful when I hook up the steppers. Well, I'm going to definitely test, or I'm definitely going to take my magnifying glass and check all these very carefully. But that was the last 3 parts as far as I can tell. Okay, I've installed the driver chips. This one's done. So the last thing to do is get a toothbrush and clean everything. And I like to use alcohol, like rubbing alcohol, like this stuff here. The higher percentage, the better. I don't have any higher than 70, but this will work. And I just squirt it on a toothbrush, and then I, clean it really well. And I'll let it dry out for quite a while before I try to apply power. But I'll go ahead and clean this board up like this, being very careful that I check everything. And then I'll let it dry out thoroughly. So we're getting close. Well, there it is. There's the completed board, and I've checked it and I've cleaned the back of it really well. So it's ready to go. So the next step is to set these jumpers. If you notice, each of the axes have their own set of jumpers, and like this one here is for the X. Okay, now the first three jumpers here set for microstepping, and without getting into it too much, microstepping is a way to add resolution to your motors. And typically I run mine at half resolution, which would be called half step. And they run fairly good like that. Now the higher you go up in resolution, the more computer processing power you're going to need. So again, I find that half stepping works good. Now if you want more details and information on microstepping, you can just Google it. But the first three pins, depending on what jumpers you have on, will determine if you have like 1-to-1 step, half step, or quarter, eighth, and 16th. And you do the same for all three. So the first three pins determine that. And then this last pin, jumper 4, for each of the three axes, that determines if you have something that reduces the current to the motors after a set period of time. Now, to reduce current and heat after, I believe it's 10 seconds of not using the machine, it'll reduce its power to half to the motor, so that the motors won't run as hot and you won't use as much current. Now that will be true if this jumper is on, number 4. If you take the jumper off, it's just full strength power all the time. And for this next step, you have to have jumper 4 in anyway, so I've got it set up. So that's what it's all about. I've got the pin set up here for half step and then current reduction on each of the three. Now the other thing that we have to set up is for the voltage reference. And these three trimmers right here are for X, Y, and Z, and they control how much current goes to each of the motors. Now depending on what size and type of motor you have on these will determine how much current you need coming out of these drivers. If you look on a motor like this one, there's a nameplate and it says 4.2 volts at 3 amp. So the maximum current draw that this motor can use would be 3 amps. And there's a formula that the hobby CNC instructions give you to set this. So to give you an idea, find my instructions. If I wanted to set this up for 3 amps, my X, because I have that large motor on, I would set this voltage reference up for 0.42 volts DC. And the formula for that is you take the desired current and you multiply it by 0.14. So if I wanted 1 amp maximum coming out of X, it would be 0.14 volts DC. And you measure that with these little pads here, X, Y, and Z, and then use your ground here. So we're going to set those up. And I'm going to just set them up for fairly low right now because I don't have my power supply ready yet. So what I'm going to do is just set them up for a maximum of 1 amp coming out of each of these. And again, it will just depend on what your motor allows. You know, it'll tell you how much. Like this one uses a maximum of 2 amp there. And really, you should only use like 85 or 90%. I wouldn't run it at a full 2 amp or a full 3 amp, maybe, like I said, 85 or 90%. But for now, I'm just going to set these up for 1 amp each, and I'll show you how to do that. So let me get my power leads back on here, the way I had it set up before with my test supply. This is just a 12-volt power supply, so I can test this. So my red on positive. Black on the ground, negative. I've got my power supply over here, set up, ready to go. Let's bring in my meter. Okay. Put my ground lead down on the ground. I'm going to go ahead and turn on my power supply now. So according to the Hobby CNC directions, if I want to set up my current for 1 amp each, I would need 0.14 volts DC on the pin. So I'm going to take my positive test lead and put it on X, and you can see that it's 0.45, so that's way too high. I'm looking for 0.14. So I'm going to take my screwdriver and put it on this pot and turn it down till I come up with 0.14 right there. So with this setting, 0.14, this will allow the X to produce 1 amp. Okay? So now I can go to my Y here. This one's not giving me anything. Let's see if we can turn it here. There we go. So 0.14, there we go. And here's the Z, that's high as well. So before you hook any motors up, you want to do this. You want to set your voltage reference. And most all stepper driver boards are the same. You have to set your voltage reference for your current reduction. Okay, so I have all of my, let's verify that, 0.14, 0.14. All 3 of my axes are set for 1 amp delivery or less, so I'm good, so I can turn off my supply. Now I can go ahead and connect motors if I want to, but you have to make sure you set that up before you connect motors. So let's talk about motors here for just a moment. If you notice all these wires on this motor, you'll have to reference the instructions that come with your motor. And I'm just going to show you the paper that they give me. This is actually this motor right here. There's a red, black, yellow, blue, orange, brown, green, and white wire. And it shows what connections to connect them to. Like my red wire goes to a capital A. And this capital A is just a coil. It's referring to a coil. There's a capital A and a lowercase a, if you notice. And then there's 2 commons. And there's a lowercase b and an uppercase b. Again, this is just a way to show the coils. So if you look right here on the side of the board, hopefully you can see this, it has uppercase B, lowercase b, there's common, which will be these 2 screws, a lowercase a and an uppercase a. So for the B, the uppercase B, I look on my chart, Now, different motor manufacturers will be different, but I'm just showing you mine. The uppercase B should be a white wire, so I have to connect a white wire to the uppercase B. So that would be this one. So I will put this one here. And then for the lowercase b, refer back to my chart. The lowercase b is a green wire here. So I find my green wire here. And I connect it on. So I'm going to go ahead and finish up the rest of these, and I'll be back. Okay, so I hooked up 3 motors, just random motors that I had laying around, and they're all different specifications. Like this is probably the biggest and the smallest. And if you notice, this one has 8 wires, and so does this one, and this one has 6. So it will accommodate different types of motors as long as it's a unipolar type motor. Now the 4-wire will not work, but 5, 6, or 8 stepper type motors will work just fine. Now this is hooked up to my parallel port, and I've got it hooked up to Mach. Let me just turn it on so you can see it run real quick. I'll start the cycle. So this would be my X, my Y, and my Z, and I'm just running the simple road runner. You can see it's working just fine. Let me stop this and I'll just run them individually. Here's my Y, here's my X, and my Z. So I still have to build the power supply, and we'll do that next time. This is way underrated. And I have to put a heat sink on here, so I'm going to have to build something up for that. And get my fans installed. And then we'll talk about these input signals for the micro switches, for the end stops and that sort of thing. And we'll talk about maybe spindle control and that sort of thing. So we still have some more to do, but I'm going to leave it here for now, and I hope you got some use out of this video. If you did, please give us a big thumbs up and a comment down below, and let me know what features you might want me to incorporate in this controller. So thanks for watching. We'll see you on the next one. Bye for now.